All right, great. All right, so before we start, any questions from yesterday's session? Uh, did you get the videos for the session? And were you able to take a look at that? I've unmuted both of you, Syed and Nageshwara.
Syed, Venkat, and Gurpal are here. So we have not got the
Right. So
access.
did you get the recorded session?
Yeah, we got it.
Yes.
You have not got this. You have got the system access?
No.
Not yet. Okay. Nageshwara? It's like his microphone isn't working. Well, did Mahesh tell you anything about when you would have the system access? Syed?
Yes. I'm sorry. Say it again.
And then, did he mention any time when you're getting the server access?
I think today is today, I guess, but not sure yet. Tomorrow morning. Okay. Tomorrow morning again we will
Right,
we will again call him. But
all right. So
if you get a chance, could you
he's
please talk to him
mentioning.
too?
I will. So you have registered already, right?
Yes.
Yes. Yes.
Okay, sure. So do you want me to go ahead with the loading of data into info objects, or do you want me to do some theory stuff?
Yeah, we cannot practice. Maybe we can proceed with theory. What do you think?
Yeah.
We are okay to go with either way because you are going to provide us the recording.
Yeah, but I don't want you to fall back on this thing because
Then
you
go
don't
ahead.
have the system.
And then go ahead and we'll start the
Theory.
theory.
All right, let's see.
And also we have not got any reading material from you. So if you get a chance, please send us that.
Sure. Sure.
Did you hear that?
Yeah.
I did. Yeah.
Oh.
I'll send you stuff. So now the entire BW system, I'm not talking about BW on HANA yet, but BW as a system, right? We have the entire schema in the extended star schema, all right? So before we get to that point of extended star schema, I'd want you to go ahead and understand what exactly do we understand by the multi-dimensional model and the extended star schema. Alright, this session that we're going to do right now is pretty much the most fundamental and most important session of the entire BW. Alright, I want you to concentrate and I want you to ask questions if you don't understand. Okay. So here what we are doing is we're trying to take an example of a shop floor, alright, and we're trying to see how multi-dimensional modeling is done using the extended star schema. Why is it not using star schema model? What are the disadvantages of using the star schema model? And how are we using it with the extended star schema? What are the errors it's trying to rectify from the star schema? That's what we will be looking at. Before we go into that, now if you go into a shop floor, alright, and you would categorize people, yesterday we were talking about that for a moment. So if you go into a shop floor, the majority of stuff that you will be looking at is a lot of customers. If you can segregate them into major stuff, it will be customers. You will have a lot of products that you will be looking at. You will have a lot of representatives, sales guys, and then all of this are arranged in the form of groups and all that. So basically you'll have customer, material, and sales rep. Alright. So let's assume that this is the kind of major segregation that we can do on a shop floor. Now, before we go to the extended star schema, your model is arranged in the form of entities. This model is called as the entity relationship model. ER model is what it is called. Here you will find that all of them are arranged in the form of entities. The ones which are the majority of what you would see in the shop floor, all of these are strong entities, alright? Customers, they don't really have to do anything else. You don't need any other information. They can exist as themselves, and these are all customer information. Even products, you don't need anything else for the materials or products. They can exist by themselves, so you don't need extra information. But these are the main ones that will take part in the business. So, and also the sales people who will help you with the purchase, the commission, and all that. So you would have these three as the main entities in our entire entity relationship model. An entity relationship model is a skeletal picturization of how your business is going to run. It will also tell you the kind of way these entities are connected, the cardinality between them. Is it a one-to-one relationship or is it a one-to-many relationship? All of that will be represented in the entity relationship model. It will give you a basis of how your business flow is going to run. In this small example, what we are trying to look at is you have the customer, you have material, and you have sales rep. So these three are the main entities in here, and you will find that these entities can exist by themselves, which means that they don't really need to interact between them. But if they don't really interact between them, you will not have any business at all. And if you don't have any business, there wouldn't be a need for a business intelligence person. What we are most interested here will be this transaction or intersection entity. The intersection entity is filled only when you have some kind of a business happening or some kind of transactions happening between the customer and the product, right? And when this intersection or interaction happens between customer, material, and sales guy, you will have the sales transaction being filled. The intersection entity data will be accumulated, and we'll be trying to organize that data. Now, over and about to the main entities, you also have something called as the weak entities. All right, the strong entities are connected to the weak entities. Doesn't mean that without the weak entities, the strong entity cannot sustain. It is always some extra information that the weak entities provide about the strong entities, allows you to analyze the data in a better way. All right, so these weak entities in BW terminology are called as attributes. All right, attributes of the strong entities, and these will provide a little more data with the strong entities. Now, these attributes, the only reason they are available is when you're trying to report this data. These attributes, you will find them depend on how you want to use the main entities. These weak entities will tag along with the strong entity in your reporting system. But you cannot have any drill down and drill across on these weak entities. If you create these attributes as navigational attributes, then even on the reports, these will have the same privileges, just like how the strong entity has. You can do drill down and drill across on the attributes as well. But if you only create them as navigational attributes, by the best practices of SAP, you shouldn't be creating more than 5 navigational attributes in one of the data targets. So we'll get that discussion a little later on. But right now what we need to understand is your strong entities and your weak entities and how your intersection entity data is going to look like. So once you have this intersection entity, you'd probably have the sales order number, sales item number, and you'd have customer number, material number, sales rep, amount, quantity, and currency. The data is going to look something like this. You would have all of this data, and you'd have the customer ID, the material ID, and the sales rep ID. Alright, the customer ID is connected to, so this is the transactions that you have done. You have bought a couple of the quantities of a material priced at 4, so your total revenue is 8. And in a similar fashion, the rest of the customers, C1 has bought M1 or C2 has bought M1. So there are multiple transactions that happen, alright, using sales reps as well. And this is the revenue that is acquired by the customer, and this is what he wants to go ahead and try to use for analyzing data. Now here, you would find that there is this customer ID. If I want to know about if he's actually my customer or no and all that information, you will want to go ahead and look at the customer master table. Okay, and this is linked using the primary key foreign key relationship from the customer ID to the customer master data table, which will consist of a little more information. C1 is the customer ID, and then you have Smith, and the address is New York. So if you want to do some analysis based on location, then going to this information about the customer master will help. Similarly, your material or even your sales rep. So they are connected using the primary key foreign key relationship. The main key is the one that is linked in here. The reason why you have the master data around is because in case there is, let's say there is a transaction created with C4 and M5, alright, do you see that as a legitimate transaction or no? The reason you will find that it is not a legitimate transaction is because you don't have a C4 customer and you don't have an M5 material. So if that transaction happened, then it is something that is out of your shop floor that has been entered. The system will not allow that transaction to happen. So for the integrity of the data, referential integrity, your data of transaction will be connected to the master data, and you will always be able to reference the transaction that has happened based on your master data values. Okay, so the OLAP system, analytical processing system, basically can handle analysis using the multidimensional modeling. Alright, so the database design for OLAP is MDM, and multidimensional modeling is implemented with 4 different kinds of schemas. One is the star schema, extended star schema, snowflake schema, and then hybrid schema. What we will be looking at is star schema and extended star schema. Snowflake is pretty much like the extended star schema, and then you have the hybrid schema. Now what exactly is a star schema? Alright, so this is an example and a depiction of how star schema is Syed. Can you hear me? Hello? Syed, can you hear me now? Hello? Syed, I've unmuted you.
Yes, yes, yes. Now we can hear you, but all of a sudden the voice was gone.
Okay, I'll repeat that again.
Thank you.
So were you able to hear from this star schema, or you even lost before this?
No, as soon as you started the slide, we lost your voice. So we are good.
Okay. All right. Just give me one moment here. All right. So this is, I've talked to you about two schemas, right? The star schema and the extended star schema. Now let's try to understand a little more about the star schema. This picture is a basic a depiction of how the star schema is going to look like. It consists of a cube, which consists of all of the transaction and mass data, everything inside the cube. All right. So this was the first model that they tried on using the star schema. And let's say this is a sales queue, and here you have all the sales information that has happened the transaction, and you also have the mass data which is connected to the transaction data also inside the queue. All right, everything that you need for the data is all inside the queue, and you're able to go and handle some dimensional modeling here. Some things that you will have to remember is the naming. It is called, the central table is called as the fact table or the transaction data table, and these dimension tables are also mass data tables or dimension table. The queue basically consists of a fact table surrounded by dimension tables. Here the dimension tables are also called as mass data tables because you have all the mass data loaded into it. Now, one constraint that you have is that you have a maximum of only 16 dimensions that you can link around the fact table. Okay, the limitation is a maximum of 16 dimensions, and then you would have you can analyze data from these 16 dimensions. Out of these 16 dimensions, 3 of these are reserved for SAP, which means you have only 13 dimensions that you can use. Okay, the 3 dimensions that are reserved for SAP is the time dimension, the unit dimension, and the data package dimension. These 3 are reserved for SAP. So let's see how we can go and make use of it. The star schema can be defined as a fact table or a transaction data table in the center of the queue, surrounded by dimension tables or mass data tables, which are connected using primary key foreign key relationship. And all of this data is present inside the queue. That's basically a star schema. Okay. The advantage for this is that you can analyze data from multiple dimensions, or at least you can analyze data from 16 different dimensions. So let's move on and look through. Star schema is a multi-dimensional model which contains fact table or transaction data table at the center, surrounded by dimension tables or mass data tables existing within the cube. These dimension tables or mass data tables are linked to the fact table or transaction data table with primary key foreign key relationship. The advantages of the star schema is we can analyze data from multiple angles, which is multiple dimensions, a maximum of 16 dimensions. That is the advantage of the star schema model. But if you look at the star schema, there are a few defects because of which we have a little performance issues with analysis of data. So let's go and look at this data, and then we'll try to see how we can counter these in the extended star scheme. Now, when I say all of this data is inside the cube, okay, so I have my customer master, my material master, and my sales rep data inside the cube. The first thing is master data redundancy. Why would I say that is, let's say I have all my customer information here, and let's say there's another cube, this is the sales cube, somebody is trying to use an accounts payable or an accounts receivable queue. Alright, in that they would want customer data. Okay, and so you will have to go and reload all your master data of customer in that queue, because this queue has the master data inside the cube, and this is not going to share the data with that other cube. So all of this master data needs to be reloaded in that individual queue. Similarly, if you're using material at some inventory or material master cubes, in that scenario you will have to go and reload all the master data of material again into that queue. If you have sales rep and then there is an HR queue, their salaries and all that. So the master data for the employees needs to be again reloaded. So the sales rep information needs to be reloaded, which means that every time you want to use your master data, you will have to reload that into that individual cube, which is a lot of redundancy in the system. Alright, so to avoid that, we need some kind of a way we can counter redundancy of master data. So the first defect that the star schema has is that redundancy of master data. The second one is, so if you have in the center, the box that you have is called as the transaction data box, right? And here this table has inputs of alphanumeric values, and this is in numerics. Okay, a straight question: do you think the system can understand numerics faster or alphanumerics faster? Your answer, I believe, is that you think that the system can
Numeric.
process numerics faster than alphanumerics, right? So
Yeah.
But you have all alphanumerics, and we're not talking about 3-4 rows of data, we're talking about 3-4 millions of rows. Alright? And when it has to analyze so much amount of data, it is better if you have all numerics than alphanumerics. So there is a performance issue in the star schema model because you have alphanumerics values in the fact table, and to process the data it will take a little more time, because of which your performance will be hit. So the second defect with the star schema model is the performance. Alright, your analysis is delayed because of alphanumeric values in the fact table.
Recording at the bottom.
The third one that you have is, I told you that there are a maximum of 16 dimensions within the info cube. So your analysis is restricted to a maximum of 16 dimensions, and out of those 3 are reserved for SAP. So your maximum number of analysis from different dimensions is 13. So if you're looking at an enterprise, and if you're looking at what kind of analysis that you could do, 13 is a very small number if you're trying to analyze from customer perspective, material perspective, sales rep perspective, company code perspective, business area perspective, division, profit center, cost center, and a few more, then your 13 dimensions are done. Alright? So if you want to do any other analysis, you don't have the possibility, because this model only supports a maximum of 16, out of which 3 are reserved for SAP. And in an enterprise you will have much more than 13 dimensions for you to analyze the data from. and this is not something that can handle more than 13. So you would have a limitation in the analysis as well. Alright, so the star schema model has these three main flaws. One is redundancy of master data, performance because of alphanumeric values, and then third one is limited analysis. What we're trying to do here is we're trying to use another model called as the extended star schema, and we will go and see how the extended star schema counters the flaws that you have in the star schema. Alright, so let's look at a little bit of explanation. So the disadvantages of star schema are mass data is not reused, mass data is maintained redundantly, degraded performance, and limited analysis. We'll see how we can overcome these in the extended star schema. So I'm taking one row of my factual data, and then we'll try to analyze data. So this is how data is linked within the star schema model. Alright, so this is the fact table or transaction data table. This is the dimension table or mass data tables. And this is basically the star schema model in which you have the cube and all of your data is inside the info cube. Alright, now let's try to answer each one and how they've countered that in the extended star schema. The first one being the mass data table redundancy. Okay, what they have done in the extended star schema is instead of having your mass data inside the cube, they said you're not able to share your mass data because it's inside the cube, can be extended to be outside the cube so that other cubes, if they need that mass data, can read that mass data. As long as you're reading, there is no exclusive lock, it is a shared lock, so you shouldn't have any problem. Alright, only if you're writing from multiple systems, then you will have some kind of an issue with the sharing of a table. But if you're only reading from it, then you shouldn't really have any problem reading from the table. So they said, why can't we move these tables from inside the cube to the outside so that those tables can be, mass data tables can be shared across multiple cubes. So now we have moved the cubes, we have moved the mass data outside the info cube. Now customer master can be used by other cubes. Material master can be used by inventory and material master cubes. You can go ahead and use sales rep in your HR. Alright. So at any place you will be able to go ahead and use this mass data exactly like how this fact table or this cube is using this information from your individual tables, master tables.
So is this maintained as a separate cubes or so how is
these are maintained as separate tables?
Tables only. Okay.
The mass data is maintained as separate tables, and you would be linking them using a shared lock across your info cube.
Okay.
Okay. So the first issue has been resolved because in the star schema model, all of it is inside the cube, but now we have moved it outside the cube so that redundancy can be reduced. Alright. The second thing that we talked about was performance or degraded performance. The degraded performance is because you have alphanumeric values inside the fact table. When you try to process millions of data using this, the system takes a while to process this or convert this to numerics, and then the numerics are processed. So instead, what the system or what the extended star schema model proposes is to have an intermediate table called as the SID table, or you call this as the SID concept, where every time you create a master data table, immediately there is an SID table that is created by the system. You don't have to bother about creating that. The system automatically creates the SID table. Alright. So the SID table basically will link your main ID with a numeric. The SID concept is for every master data information entered into the table, you would have an SID value entered into this table. So if I have C1 Smith New York, that is recognized by CID, and the CID is represented by a numeric here. And this numeric is what will go into your fact table in your transaction data. So here it will be replaced by 1. In a similar fashion, every master data table will have an SID table that is created along with it, and instead of actually bringing the alphanumeric value, you will bring in the numeric associated with that alphanumeric value in the SID table. So the SID concept is to bring in numeric values instead of alphanumeric values into the fact table so that the performance can be increased. If you bring in numerics, the system is able to process the data much faster. Now if you look at this table inside the info cube, the fact table, you will find that the entire data that you have is in numerics. So do you think the performance will be improved or no?
Yeah.
Right? So absolutely right. So you would have the performance improved because you have all numerics inside the fact table and it's not alphanumeric values. Now over and above this, you would, so the second issue of having alphanumeric within the fact table and performance degradation is countered because you have the SID concept moved into the extended star schema. Okay. The next step to this is the third issue that we have is limited analysis. Why did I say limited analysis? You were having a maximum of how many? Only 13 dimensions or 16 dimensions, out of which 3 are reserved. So you have only 13 dimensions that we can use for analyzing data. 13 different mass data tables can be connected, so that is an issue. So far I haven't mentioned anything about dimension tables. Alright? The info cube, be it extended star schema or star schema, inside the info cube you will have a maximum of 16 dimensions only. Okay? But I have not mentioned anywhere about dimension tables. So let's bring in the concept of dimensions. So this is the first step where we have mass data tables extended out, and then you have the SID concept. And these SIDs will actually link into the dimension tables. Okay. So till now I have not mentioned anything about dimension tables, but dimension tables are already there in the info cube. So the dimension tables, the SID tables will first link to the dimension tables. There will be a dimension key, and then your SID will link to that dimension key. And that's the value that actually goes into the fact table. Alright. So you still are retaining only numerics inside the fact table. Yeah? Wait, are you following me till here?
Yeah.
Alright, so you have the fact table and all of these are numerics inside the fact table. Now instead of the SIDs linking directly to the fact table, we have brought in the dimension tables, and you have the dimension key actually linking to the fact table. But did this improve any kind of analysis? You still are connecting one SID to one dimension table, and that dimension table is connecting to your fact table. It didn't improve any performance or analysis. It actually added an extra join between them, which actually slows it down. So this is not something that improves anything. You still are having a limitation of a maximum of 16 dimensions. Here I am depicting 3, but you can have a maximum of 16 dimensions. Now we need to improve that. So what the extended star schema model considered is, now you know a table, right? What is the maximum number of columns that are available in a table?
No limit?
Which one?
Is there any limit? I don't think so.
You sure?
Don't know.
Extended.
Don't know. Maybe 999 something.
No, you can have a maximum of 255 columns in a table. Alright? Ranges from 0 to 255, or you can have 256. So
And by
255 is
looking
the maximum.
By
Sure.
looking this, how we are saying that we have a 16 dimension limit, we are out of cube, all the master tables are out of cube.
So all the mass tables are outside the cube, alright? So one mass table can connect to one dimension here, alright? So how many can you connect to the info cube? How many dimensions are there in the info cube? A maximum of 16, right?
yeah,
So how many mass tables can you connect?
13.
16 mass tables, right? 3 are reserved for SAP, so you have 13, or you could say 16, generically, let's speak. So you have 16 mass tables that you can connect. So beyond that, how do you analyze data? So we really haven't changed anything on the analysis perspective.
Okay.
Yeah. So we want to improve that. So 16 is a very small limited number. We want to have more than 16. Alright? Because in an enterprise you will have different ways of how you need to analyze data, and your object should be ready for it. So here what we've considered is, now this table has 3 columns, this table has 2 columns, and this dimension table has 2 columns. So this is also a table, which means that it has a maximum of 255 columns, but here what we're using is only 1 or 2 columns. So what they thought is, why can't we go ahead and add more columns to this particular dimension table. Okay. So I have used this as SID underscore MID, and I have SID underscore sales rep ID.
So in one direction.
Okay. So this one connects in here, 2 connects in here. So you would have 2 here, and then the sales rep is 3. So this one connects in here. In one table, I have 3 different mass tables connected. Okay. But how can this happen? Which means that if you have 3 tables connected, that is a unique value of dimension key that is coming in here. Okay. How is this possible is, so let's say you take a table. You have customer C1 buying a material M1 using the sales rep S1. If this kind of computation happens, this is equal to 1 dimension key. It need not be C1, M1 and S1. Let's say it is C1, M2 and let's say S2. This is a second computation. So this will have a different value 1 here. Let's say 1. This will be 1. Material M2 has a different value, let's say 4. And you would have sales rep 5. So this combination will have another dimension key. So your dimension key is based on the unique combination of these mass data and your customer number and your material ID and your sales rep ID. So a dimension table can accommodate more than one SID table. If I ask you what is the maximum number of SID tables that it can accommodate, a table has a maximum of 255 columns.
Multiply by 16.
Yeah. Out of these 255, 6 of them are reserved for SAP. Alright. So you have a maximum of available columns as 249. Okay. Out of these 249, the first column that you have is a dimension key. Okay. Which is -1, versus the remaining columns are 248. So these 248 columns can connect to 248 different mass
SID.
data tables or 248 different SID tables.
Wow.
So which means that in one dimension alone, if you are considering the maximum number of SIDs it can link to 248 different SID tables. And if you are linking to 248 different SID tables, it means you are connecting to 248 different master data tables. So one dimension can connect to 248 master data tables. Okay, and if it is 13, how many?
Ooh.
It will be
Mean
248 into 13, close to some 3000.
wow.
Okay, so this is the maximum limit of how many SID tables you can link, which is how many master data tables you can link. 13 times 248, close to 3000. Okay, that is the improvement that the extended star schema has brought in for analysis. Instead of having 13, you have 13 times 248. You don't really use 248 all times, but that is the capability of the modeling schema in the extended star schema. Alright? So here you need to remember some things. Two golden rules. One is you don't want to have too many dimension tables, or you don't want to have too many dimensions. Okay? Less number of dimensions. And the second golden rule is that at any point of time, your dimension table should be less than 20% of your fact table. What I mean to say is, it should be less than 20% of the amount of data on your fact table. If your fact table has 100 rows, your dimension table should not have more than 20 rows. If it has, it will have performance issues. Okay? You will have to model in such a way that this ratio always maintains. You don't want to have too many dimensions. Here I have, for each column I have created one dimension. Instead you should see if you can accommodate all of these in the same dimension. Also, you should see this fact table should be, or the dimension table should be less than 20% of the fact table. Okay. How can you maintain this depends on how you are modeling your data. Let's say I'll move from here. Let's say I'm going to open an Excel. Customer. So I have customer C1, customer C2, and customer C3. I have material. I have two materials, let's say M1 and M2. What is the maximum number of transactions that are possible, or what is the maximum number of combinations that are possible between customer and material?
Or 3 multiplied by 2.
Yeah?
Uh,
How many?
Can you repeat the question though?
I have three customers. I have two products.
Yeah.
Okay. How many possible ways are there that customer can buy the products? Or how many transactions are possible?
13 probably.
These are three. These are two. Okay. C1 can buy M1 or he can buy M2. C2 can buy M1 or M2. C3 can buy M1 or M2. Any other transactions possible?
No.
Yeah. So this is 3. This is 2.
6.
Total number of transactions is 6. So if you include both of these master data tables in the same dimension, okay, you will have C1, M1, C2, M1, C3, M1, same thing, C1, M2, C2,
9.
M2, and C3 and M2. So you have a total of, in the dimension table, how many you would have?
6.
6. Okay. Now it depends on how you are grouping your values. So your transactions between these, so C1 can go and buy M1 any number of times. Okay. So each time you buy M1, you will have a transaction data created. Each time you buy M2, you will have a transaction data created. So you can buy 100 times, but your dimension table, the combination for C1 and M1, let's say, is 1. Okay. So into the fact table, it will push only 1. Every time C1 buys M1, it has a number that it is loading. So that is directly the value that will go into your fact table, right?
Mm-hmm.
C2 is buying M1, it will have, let's say, 2. He can buy C2, C2 can buy M1 any number of times. The dimension value is 2. So it is already reserved. Okay. So in a dimension, the different kinds of SIDs that you are bringing in, the combination of it will be depicted by a value, a unique value. So that is why when there is that combination, the system automatically sends in that unique value. So if you have multiple dimensions, the combinations of that will increase. So let's say here I go and add, instead of material, I have sales rep. So if I have 2 sales reps, S1 and S2, so how many combinations it will be? C1 M1 can buy S1, C1 M1 can be done with S2. Alright, this whole thing into 2, right? Because you have 2 values, which is your maximum dimension table length will be 12. You should be very careful as to how you will design your, so let's say you have 1000 customers and you have 400 materials. What is the size of your dimension table?
400,000.
400,000. If your dimension table itself is 400,000, your fact table should be 100 times more than that. Alright?
Yes.
Which is, or at least 80% more than that. Let's say we'll take it 100, 400,000. If your fact table has so many entries, then your dimension table can have these many entries.
You're talking about rows only, right? Like fact table should have, for example, 100. So then dimension table should have only 80. That's what you mean,
No,
right?
it should have less than 20.
Or less than 20, like 20 only then.
20 only.
Yeah. So here, if your combinations between C1 and M1 are a maximum of 6, you can have, the 6 is, you should think it as less than 20% of the number of fact tables. So you should have at least 50 are the number of transactions that should be created.
So,
So
from, like, for example, like customer is like, let's say 100 customers or 100 million customers we have, then in the fact table we have only, I mean, that dimension will be like fixed, right? But fact table will increase. We don't know the limit, right?
Depends on the sale. Yeah.
So let's say your materials, number of products that you're creating increases, or let's say number of customer base increases, then your dimension table also increases.
Yes.
So that is a flaw in how you're designing it.
So
Okay.
dimension table, let's say it's not increasing, but the fact
If
table
it is not increasing, then definitely it's a good thing.
Oh, then it's
So here, if you have only a particular set of customers and materials, if this is going to be 6, it is brilliant, because the number of transactions based on just these 6 transactions will be much more than 50 or 60, in which case this is a brilliant model. But let's say your customer base is increased, and which means you need to add in more customers. So if you have 1000 customers and still 2 materials, you will have 2000 dimension table. Okay, so 2000 unique values of dimensions will be created. Whenever they transact, that value will be sent to your fact table. So instead of sending individual C1 value and M1 SID, it will send the combination ID,
Yes.
right? So you should always make sure you will link your dimension in a good way. In this example, I had 3 customers and 2 materials. Okay, I'll give you another example.
No, but in this case, we need to know the fact table volume also, right? Then only we can be able to model the data.
Right, so you need to understand whether there will be actually facts created. Yeah?
Even the fact table also we need to know. Yeah.
Yeah, in the beginning, your fact table is not that much
Yeah,
volume because as you are starting,
Right.
But over the time.
over the time it should,
Yeah. We need to model by looking at over the time.
So let's say in this example, I have, let's say, region as one of my mass tables, and then I have city. Okay. North, and then I have south. Okay. Just giving a few cities from India. In the north, let's say I have Delhi, Shimla, Jaipur. This is Srinagar. In the south, I say Hyderabad, Bangalore.
Hyderabad in south?
Yeah, way south. Chennai. And let's say Trivandrum. Okay. So how many regions are there?
8.
2 regions, right? How many cities are there?
8.
8. So your dimension, if I include both of them, how many dimensions will be created? 16, right?
Mm-hmm.
But if you look at it, will there be ever a transaction from the north region and south city?
Can be.
Like?
No. No.
Uh-oh.
No.
It is not a possibility, right? You cannot be making a transaction from the north if your sales area is in the north. Okay? And that's from a particular city. It can never happen that your north region can do a sales from your south city. In the same way, south city can never do a transaction from your north city.
Right.
So your maximum number of dimensions that you will get is not 16, but only 8. You getting my point?
Mm-hmm. Yeah.
So when you model your data, you have to even try to keep the number of dimension, the size of the dimension table smaller. If you usually link it with logically connected objects, then your dimension table is usually kept low. If you bring in customer and material, okay, these are not logically linked objects. Your customer base might increase. One day you might have 1,000, the next day you might have 1,200. Alright? Your material might be constant. You will be providing 200 different kinds of products. Because of increasing customer number, alright? Or let's say your sales orders. So your sales orders for every customer will have to be increased. So let's say the sales orders are 1,000 and number of materials is 200. So your dimension here is going to be 20,000. So next day, let's say instead of 1,000, you have got a good base. So your sales orders has increased. Instead of 1,000, you have 4,000, which means your dimension table is now not 20,000, it's going to be 80,000.
80,000.
Alright, so it is exponentially increasing because of one SID or one mass table exponentially increasing its value.
But
So in that scenario,
in this example, we are both in that dimension as well as the fact table increasing. You are talking about the transactional data.
right. So let's say you have 4,000 sales orders that is increased. So you will have to have at least 80,000 transactions in your fact table.
Yes.
How that can be.
And if 80,000 is the dimension, 80,000 into at least 80 times.
1,000.
and you might usually not have so many transactions because of one sales order. What I'm saying is, instead of having, because this combined with any other number will exponentially increase. So if I can keep this as a separate dimension without linking with anything else, my maximum number will remain 4,000.
Yeah.
Right? So that concept is called as line item dimension. A line item dimension is a concept where I am not going to link a particular SID table or a mass data table with any other mass data table, because it is going to exponentially increase, which means the dimension table will exponentially increase, which will kind of destabilize the model and the performance. So instead, we will go ahead and keep that particular column or that particular mass data table in a separate dimension. That is called as line item dimension. Usually your sales order numbers will be connected as a line item dimension.
So in case the balance get out, so what we do? So like we need to create a new model or something?
You create a new dimension, take this off from this dimension and then create. So when you design a cube, it'll take a while to analyze all of that. Okay. So in theory or in practicals, what we will see is how do we go and create a cube, what are the steps involved, these are the dimensions, so this is there. But when actual discussions happen at the blueprint phase, what happens, we look at all these possibilities. What if our customer base increases? What if at some time we choose to increase the number of products that we're going to bring? Can we go ahead and bring them under one dimension? How is our report going to look like? So all of these will be discussed at that phase, right? And all the possible values that can be derived from it will be included into the actual model creation.
And there is no limit on creating cubes though, right?
There is no limit as such. All right?
Okay.
Any questions, guys?
No? Very interesting.
All right. So this is the extended star schema model, and we are aiming at trying to overcome all the flaws that we have seen in the star schema model. So we had one redundancy issue which we countered by moving the mass data outside the info cube. You had the performance issue that has been improved by bringing in the concept of SID. And the third one is limited analysis that was improved by bringing in multiple SID tables into the same dimension. If you are able to understand these three concepts really well, then half your job will be done in the BW environment, because the entire BW environment will follow the extended star schema model. All right. So once we go ahead and create objects, I will show you how these tables are created, where do you find the links to these tables, why do we have 248 maximum. So all of this I will be able to show it to you. All right. So I'm expecting that if you guys can have the server by tomorrow morning, then we can go and do our practical sessions. The first one will be creating info objects. So in that session I'll tell you how the SIDs are created and how we can go ahead and link them with your transaction data.
Tomorrow we cannot attend the class because tomorrow is our traveling day.
Okay. Let me just speak to Mahesh and then we will see if we can take that session off.
I think we didn't get you. So tomorrow we cannot attend. So are you going to conduct a class for others or?
No. I think we will not have a session, but we'll just send out a formal email as well.
Okay.
All right.
Okay. Then the next is Monday or?
I'm going to do a session on Monday. Okay. So that email also will be sent to you.
Okay. Okay. I think
right,
we
yes,
got.
So I'll send you.
We just got the email from Mahesh about the connection, server connection. We got that one.
Okay. Great. All right.
One suggestion is like we can do instead of an hour, we can do hour and a half. So we can do.
Let's see. Like
I surely can do. The only thing was that we did not have a server connection. I don't mind doing a couple of hours also.
no. Let's see. Like if this is going well, like we'll see. Like if we need it, we can do that.
Yeah, on the weekdays for sure, we'll be doing it an hour and a half. This is the beginning sessions, and since we did not have a system, I kind of controlled it to an hour and 5-10 minutes. So once you have the server, because there'll be a lot of navigation that we'll be looking at and talking about theory stuff and then including that into practical, will automatically take it an hour and a half to 2 hours.
So since we don't have a session till Monday, then any expectation from us that we did what we did yesterday? Just try to.
Yeah, take a look at that. Today's concept is very important. I'm going to send you this presentation that I showed you. So
Okay.
I want you to go and take a look at that. Then you could,
The way I see it, like we should not study ahead, right? We should just follow what you are teaching, right?
no, if you study ahead also is fine. I'll give you some material. But the thing is, I've refined what all is there in that material because there'll be a lot of explanation. Sometimes you might find it a little too much.
It's better for us actually. I like that.
Yeah, so I will try to put in all that in a way that we can understand easily, because that is aimed at for people who already have warehousing knowledge or who already have BW knowledge. So instead, if you can listen to me first, and then if you can go ahead and read that through, then it will make more sense.
Yeah.
Okay.
We agree.
Definitely.
All right.
Okay.
All right, guys. Thanks
Thank
for
you.
coming for the session. I will see you around on Monday.
Okay. Thank you.
All right. Yeah. Bye, guys.